Hello guys and welcome back to the reaction zone. In today's lesson, we're going to continue with balancing of Redox equations in acidic medium using the ion-electron method. Now we have this Redox equation on the board which we are to balance in acidic medium. This Redox equation has 6 different chemical species. So the first thing to do is to split it into 2 half equations, the oxidation half equation and the reduction half equation. So the first one is MnO4 minus plus H plus is going to give Mn2 plus H2O. So this is one of the half equations. And then the second half equation will be Fe2 plus to give us Fe3 plus. Now to determine which of the half equations is oxidation and which one is reduction, I can look at iron. The oxidation number of iron here on the left hand side is plus 2. The oxidation of iron here is plus 3, so there is an increase in oxidation number. So it means that this is the oxidation half equation, and this one here is the reduction half equation. So starting with the first half equation here, let's balance the atoms and the charges. So we'll have MnO4 minus plus H plus to give us Mn2 plus H2O. Now let us look at atoms that are neither hydrogen nor oxygen. Manganese is 1 here, manganese is 1. It is balanced. Okay, so now to balance the oxygen atoms. There are 4 oxygen atoms on the left hand side. There is just 1 on the right hand side. So there is a deficiency of 3. So what this means is that we add 3 molecules of water to this side. And when that is done, you can see that the number of oxygen atoms becomes balanced. Now this creates a deficiency in the number of hydrogen atoms. There are 6 plus 2, that's 8 hydrogen atoms on this side, and there is just 1 here. So what I'll simply do is to add 8 in front of this, and the hydrogen atoms are now what? Balanced. So I can rewrite this equation as MnO4 minus plus 8H plus become Mn2 plus 4H2O when I add 1 molecule of water to 3 molecules of water. So the next thing will be to balance the charges. On the left hand side, let us find the net charge. Minus 1 times 1 is minus 1. Plus 1 times 8 is plus 8. This gives a net charge of plus 7. Plus 2 times 1 is plus 2. So what do we do to plus 7 to become equal to plus 2? That is to add 5 electrons to this side. Because by the time we do that, we'll have minus 1 times 5 will give you minus 5. And the net charge on both sides becomes equal. So this is equation 1. The second half equation does not have oxygen, and the atoms of iron are balanced. Iron atoms on both sides are balanced. So you just bring it down. This is Fe2 plus, Fe3 plus. On the left hand side here, the net charge is plus 2. On the right hand side here, the net charge is plus 3. So what do we do to plus 3 to make it become equal to plus 2? is simply to add one electron here. Because when you do, you have minus 1 times 1, minus 1, and the net charge here becomes plus 2. So, this is our equation 2. The next thing now is to balance the electrons in both half equations. There are 5 electrons in equation 1, there is only 1 electron here. So that means if you multiply equation 2 by 5, the electrons in both sides will be, in both half equations will be the same. So equation 2 multiplied by 5 will give 5Fe2 plus, give 5Fe3 plus 5E minus. So this becomes equation 2. Then I can rewrite equation 1 underneath. And this will become MnO4 minus plus 8H plus 5E minus. We give Mn2 plus 4 molecules of water, 4H2. So at this point, you can cancel out the electrons. Now, it is important for you to note something here. When you are trying to balance Redox equations with ion-electron method, and you get to the point where you have balanced the electrons in both equations, note that in equation 2, the electrons are on the right hand side, and in equation 1, they're on the left hand side. If by the time you get to this point, the number of electrons in both half equations are on the same side, meaning that these 5E minus and 5E minus here are either both on the left hand side or they are either both on the right hand side, then there is a problem. It means that you must have made a mistake in the process of getting to this point. So you must please note that if the number of electrons in one of the half equations is on the right side, then the number of electrons for the other half equation must be on the left. So note that the number of electrons in both half equations must not be on the same side. So we can add both equations now to get our final answer. So this will be 5Fe2 plus MnO4 minus plus 8H plus will give us 5Fe3 plus Mn2 plus 4H2O. And this is the answer to this question. To ensure or to check if the atoms on both sides as well as the charges on both sides are balanced, let us list the atoms. Check. Left hand side, right hand side. So we have iron here on the left, we also have iron on the right. We have manganese on the left, we have manganese on the right, we have hydrogen on the left, hydrogen on the right as well. We have oxygen on the left as well as oxygen on the left and the right, and then charges. On the left hand side, the number of ion atoms is 5. On the right hand side as well, the number of ion atoms is 5. On the left, the number of manganese atoms is 1. On the right, the number of manganese atoms is 1. On the left, the number of hydrogen atoms is 8. On the right, the number of hydrogen atoms is also 8. On the left, the number of oxygen atoms is 4. And on the right, the number of oxygen atoms is also 4. And let's find the net charges on both sides of the balanced Redox equation. Plus 2 times 5 will give plus 10. Minus 1 times 1 will give minus 1. Plus 1 times 8 will give plus 8. So the net charge here will be plus 10 plus 8 will be plus 18 minus 1 will give us plus 17. And then, let us look at the right hand side. Plus 3 times 5 will give plus 15. Plus 2 times 1 will give plus 2. And the net charge here is also plus 17. So the fact that the atoms on both sides are balanced and the charges on both sides are also the same tells you that this answer is correct. Thank you very much for watching and see you in the next lesson.